Hello everyone, welcome to the channel Physics Fun. So this is the second video in JEE Mains Communication System series. So in this video, I am going to solve all questions of March session of 2021, right? So there are 4 or 5 questions and all the questions are based on the same concept which we have discussed in last video, right? So 1 or 2 new concepts will come. Those concepts also I will be explaining, and total in 10 minutes, you will learn those concepts also, and you will also learn how to solve those questions, right? So like I said in previous video, let me repeat, this is a very, very important chapter. If you want to get percentile, which is more than 99, then this chapter you can't afford to leave, because in each and every set of 2021, there is one question from communication system, right? That question, sometimes it is in first section 1 to 20, where you don't have a choice. Sometimes it is in second, right? So you never know, it might come in 1 to 20 also. If it comes in 1 to 20, you don't have a choice. So better to learn. It's very, very just 2-3 things you have to learn, and you will be able to solve the questions. Fine. So let us now straight away go to the questions. So first question is, there is a 25-meter long antenna. It is mounted on an antenna tower. Height of the antenna tower is 75 meters, right? So length of the antenna is 25 meters, height is 75 meters. Wavelength in meter of the signal transmitted by this antenna would be, right? So how do we find what is the relation between wavelength and the length of antenna? Wavelength and length of antenna, this we discussed in previous video. We can discuss this again. Very simple relation. The antenna, minimum length of the antenna should be lambda by 4, right? So if length of the antenna is lambda by 4, then the transmission optimization happens. Fine. So power radiated is also maximum, and then other regions also we discussed in previous video. So here, what is the length? Length is 25 meters. You have to find the wavelength. Simple. If you just know this as a fact, length of the antenna is lambda by 4. Lambda by 4 is 25. Lambda is equal to 100 meter. Question solved, right? So nothing can be simpler than this. Fine. I hope you have understood. Let us move to the second one now. So second one is, now there are 2 identical antennas mounted on identical towers, right? So this is one tower you are seeing. This is another tower. This diagram I have taken from NCERT. They are separated from each other by a distance of 45 kilometers. So this is 45 kilometer distance. What should nearly be the minimum height of receiving antenna? This is receiving antenna to receive the signal in line of sight. Radius of Earth is given, right? So here we need to discuss a few things. This is basically which type of communication? This is line of sight communication. This comes into what category? This comes into space waves category, right? So there are 2 more modes of transport. There's one ground wave, which is used for low frequency, and there is one sky wave, which is used for middle range frequencies, right? You should also remember roughly you should also remember the range of frequencies. That question also have come once in mains. So now this is height of the antenna, transmitter antenna, and this is the receiver antenna. HR is the height of receiver antenna. And this is the maximum distance between these 2 antennas, right? Maximum for what? Such that the signal transmitted from this antenna can be received by this antenna. Otherwise, if you increase this distance even more, then what will happen? Due to the curvature of Earth, line of sight मतलब एक को दूसरा दिखना चाहिए, है ना? Then line of sight communication will not happen because of the curvature, right? तो अगर आपने यहाँ पर एंटीना बनाया, see where I'm pointing, then it might happen that it can go up to here, and if it is coming here, due to the curvature of it, it will not be able to reach directly to the receiver antenna. So that is why there is a relation between DM and height of transmitter antenna and height of receiver antenna. Fine. What is that relation? So this is the figure. Fine. Line of sight communication and space waves. All these are important points. This is one important. I will highlight this, right? So this is the figure. The maximum line of sight distance DM between the 2 antennas having height HT and HR above Earth is given by DM is equal to root 2R HT 2R HR. ST is what? Height of transmitter antenna. HR is height of receiver antenna. Here HR is height of, that's the same thing as written. Fine. So let us now see how do you get this first. Okay. So for this, the same diagram I have used, and in a very simple way, we will understand how do you get that. So for this transmitter antenna, here, when this line becomes tangent to the curvature, tangent to the earth, right? This is the maximum distance signal can reach. Fine. If this is receiver antenna, then this is the maximum distance from which this receiver antenna can receive signal. So I will be finding dt. Similarly, you can find out dr also, and you get total distance. So to find out that, see this triangle? This is center of earth. Now in this triangle, I'm going to write one line. You will understand what I'm writing. I'm writing r plus ht whole square. What is r plus ht? This distance is r plus ht. This is equal to r square plus dt whole square, right? So this triangle I have taken. R square plus dt square is r plus ht whole square. If we open the square, r square plus ht square plus 2r ht is equal to r square plus dt whole square. Fine. Now you can see r square cancels. And here, since ht is very small as compared to radius of earth, then this ht square you can neglect. कितना होगा height of antenna? How much? You see many antennas, right? कितनी height हो सकती है? Maximum it is 400 meters, 500 meters, right? That is also very high. So this we can neglect as compared to the here. What is r? R here is radius of earth, right? So as compared to r, this ht square is very small. So if we neglect this, we get that formula which was written in NCERT, 2rht, right? Likewise, you can also get this distance, which is going to be what? 2rhr. If you add these two, you get this total distance, fine? So the same formula, very simple. Even if you forget the formula, just in one line, you can derive the formula, correct? Okay, so that's the formula now. Let us see this question. Question was the distance between two antennas is 45 kilometers. This diagram is not given in the question, right? This diagram I have taken from the NCERT. What should nearly be the minimum height of receiving antenna to receive the signals in line of sight? And there are two identical antennas. Fine. So there are two identical antennas. What is the sensible thing to do? ST is equal to HR. And then see here what I've written, D is equal to 2 times 2R HR. Make sense, right? What we have to find out, D is given here, 45 kilometers. R is also given, 64. We have to find out height of the antenna. So just very simple calculation. HR is equal to D square by 8R. D is 45 kilometers. R is 6400 kilometers. Will give us 39.55 meter, right? So that is the height we are talking about. Height of the antenna is nearly 40 meter. Height of the radius of the earth is 6400 kilometers. So that is why we neglected there, right? It's a very good approximation. Fine. But this is again a very important question. You will see that there are many questions in 2020 also, which are based on this, right? So in communication system, the most important thing is amplitude modulation. The second most important thing is this, as far as questions of JEE means are concerned. Fine. Let us move to the next one. Next question is again based on the same concept. This is for VHF. What is VHF? VHF is very high frequency signal broadcasting. And this is numerical question. So here we have to fill the value. Kilometer square of maximum service area will be covered by an antenna tower of height 30 meter. So you know the height of antenna, 30 meter. If the receiving antenna is placed at ground, right? And let the radius of earth be 6400 kilometer. So receiving antenna doesn't have any height. So what will happen now? See, this is the antenna, correct? And this antenna will give signal up to here. We have seen when this line becomes tangent to the surface of earth. So this is D, this is also D. We have to find out the area. D is equal to root 2 RHT, the same formula. Area is pi d square. That's it. Question is solved. So pi d square is what? You understand this, right? See here, one small assumption we are taking. You are saying, you might be thinking that, okay, this distance, we should be finding this area, right? That's okay. But see, as compared to the curvature of Earth, this is almost a straight line, right? Radius of Earth is 6400 kilometer. And then how much area one antenna can cover? that is almost flat. Okay, so that is why we can take this D and consider this as a circle, right? Flat area. So area is pi d square, D is radius here, correct? And then D we can substitute 2RHT, R is given, pi is also given, and then HT is 30 meter, and then we get 1206 kilometer square, right? So the antenna of 30 meter can cover 1206 kilometers square of Earth area. At all those places, it can send signal. Fine. Same question, same formula, right? Next one, let us see. Next one is again amplitude modulation. Very, very simple question. Let us see. Carrier signal is given and then amplitude modulated by a message signal. This is message. In last video, we have seen it is transmitted through an antenna. What will be the bandwidth? What is bandwidth? See this diagram again. In last video also we have seen this. So this is the lowest one. This is highest one. Bandwidth is the difference of these two. So if you uh, take the difference, it becomes 2 omega m, right? So bandwidth is 2 omega m, which is modulating signal. This is the modulating signal. How do you identify which is modulating signal? Modulating signal will have lesser frequency and carrier signal will always have more frequency. So reason we have discussed in previous video. So this is 2 into omega m. So this is omega, right? So it is 2 into 1.57 into 10 power 8. But if you see, options are given in hertz, right? Some other unit of hertz. So if options are given in hertz, then we have to, how do you convert radian to hertz? Omega is equal to 2 pi f, right? So this I have, that is why I have divided here by 2 pi. This is 1.57. So we can take the value of pi as 3.14. And then if we solve, we get 50 megahertz, right? So this is the correct answer. Very, very simple question. Okay, let's see the next one. Next question is again, a TV transmission tower antenna is at height of 20 meter. Suppose that receiving antenna is at, again, same question, ground level. Ground level means there is no height, almost zero height, height of 5 meters. So receiving antenna in two cases, one, you can consider height of receiving antenna as approximately 0. Here it is 5 meter. Then the increase in antenna range relative to the case one is n%. So here, one thing which you should remember, and accordingly you should answer in your mains exam also, when they're talking about range, they're not talking about area, right? So if they want you to find range in terms of area, then area will be mentioned somewhere. If only range is written, you have to find out the distance. Fine. So this was the confusion. Some student thought this as area and then they calculated percentage in terms of area. That you don't have to do. So same thing now. So this is what tower antenna height 20 meter. Increase in the range will be here. What is the range? 2R HT, right? So total range is what? Total range is root 2R HT plus root 2R HR. In first case, ground level HR is 0. So just range is 2R HT. That is what I've written. HT is 20 meters, root 40R, correct? Now, when this is 5 meter, then HR is 5. So root 40R plus root 2R HR, which is root 10R. So this is the case range in second case. Now you have to find out percentage increase. So what is the percent increase? Increase is this minus this, root 40R cancels. You get only root 10R, right? Divided by the original one, which is root 40R. You take the percent, you get 50%. Very simple calculation. R cancels 1 upon root 4 is 200 by 2 is 50%. That's it, right? Very, very simple questions. Okay, so now next one. Yeah, I think that's it. These were the questions. There was one more question, which was theoretical. So that question I have left. Now, see, again, in previous video and this video, the only one thing which I am requesting you, don't leave this communication chapter, right? Even if it is not taught in your coaching, then also you can just go through these formulas, go through these two videos, and 100% you will be able to solve the question, right? And another thing is, from the trend of 2021, in your set also, in 2022, 100% you are going to get one question of communication systems, right? So don't think that question will come in optional, I can leave that. See, the point is, if question comes in optional also, in section 2 also, then also it is always beneficial for you to attempt this question, right? See how much time it will take to solve this question. 30 seconds, right? How much time it will take to solve this question? 20 seconds. Even if it is an optional, you should solve this question, right? Because other questions of mechanics, electrostatics will require certain, you will have to at least write the formula, then put the values. It will definitely take more time. So these are all free marks. Even if you have not studied till now, you can again open NCERT, just go through the NCERT once, or if you have not done anything, just watch these 2 videos. 100% you will be able to solve the questions. So tomorrow I'm going to upload next video in which for the next session also, I will compile all the questions and then make a video for you, right? So thank you very much for watching. And if you have liked this video, if it is beneficial for you, then please subscribe to this channel and hit like button also. So when you like this video, then according to the YouTube algorithm, this video, YouTube will show this video to other viewers also, right? And then that is how views will increase. So that's it. All the best. Thank you very much. We'll meet in next video. Thanks a lot.